Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today, we're going to be talking about how to write names and formulas for simple ionic compounds. So the first thing is kind of a review, but cations, remember, they're positively charged. They come from metals. Metals are found to the left side of the zigzag line on the periodic table, and they always come first whenever you're naming an ionic compound. After that, you have your anions, and so anions are negatively charged. They're found on the right side of the periodic table's zigzag line. And we also had a bunch of polyatomic ones, which you don't need to memorize, but they were things that are on your formula page. So you have like, sulfate and phosphate, acetate, things like that. Now, another little fact, if you want to call it that, are that a lot of the times when you look at the formulas for ionic compounds, you'll see little subscripts. And subscripts are just those small little numbers. And occasionally you'll find parentheses. But it doesn't matter what the subscripts say or the parentheses when you're trying to name a simple ionic compound. They actually don't affect anything when you're naming it. And so here are some examples of subscripts. So you've got, Al2, SO4. Notice there are parentheses and there are subscripts, but all that matters is Al is your cation, and SO4, that would be your anion. That's all that matters. These parentheses, these little subscripts here on the outside don't matter. And that would be aluminum sulfate in case you were wondering. So let's circle our cations and let's put a box around our anions. So notice we have Na, that would be our cation. Cl, that would be our anion. NH4, that would be our positively charged thing, our cation. O would be our negatively charged one. Ba, positive. NO3, negative. K, positive. P, negative. Notice I don't care about these parentheses and I don't care about the little subscripts that appeared in these situations. And so Na is sodium. What is Cl? Do you remember how to change anions' names? That would be chloride, because that's chlorine, but it's an ion, so it ends in ide. What about NH4? You have to look that one up. It's ammonium. O, how do we change it? Oxide. Oxygen becomes oxide. Ba, barium. NO3, again, look it up on your formula page. It's a polyatomic ion. It's more than one. Nitrate. K, that's potassium. P, that's phosphorus, but remember, it's an anion if it comes second. So that would be phosphide. That's how you would name those. See how easy that was? Now, this is our flow chart. So the first thing you have to ask yourself is, does the compound have a metal or ammonium in it? All of the examples we just did either had a metal at the front or had NH4+, which is ammonium. Now, if the answer to that is yes, the way you name it is as if you're naming an ionic compound. Then the next thing you ask is, does it have a transition metal? None of those things were transition metals. So if no, name normally. And so what does normally mean? You name your cation, then you name your anion. Simple as that. Now, how do we write the formulas? That gets a little bit harder, right? So the first thing you do is you write the symbol and the charge of your cation, and we're going to use the generic symbol capital A for any element, and then Q+, that would be the charge. So that would be like, 1+, a 2+, 3+, and then our anion, that comes second. We're going to make that B, and then we're going to use Z- as that. So how do you write a formula for something? Those all had little subscripts, or some of them had parentheses and things like that. How do we write those? Well, the next thing you do is you crisscross your charges. So Q goes down here, Z goes down here. And remember, when you do that, you get AZBQ. So the Z goes here, the Q goes there. Notice plus or minus is never included. These pluses and minuses, they don't carry downwards. So you don't have like a plus or a minus anywhere down here. So let's try to do that. So also, why do we crisscross, right? So it seems like a weird rule. Why do you put this here and then, imagine putting a 1 or something here? It's because the charges of the cations and anions have to be neutral. So everything has to balance. If I have a +1 and a -3, I can't put those together and make something that's neutral, and so I have to be able to change that somehow. And the way you do that is by crisscrossing. So if I crisscross by putting a 3 here, and notice I didn't crisscross because this is a +1, and there's nothing here. There's nothing for me to crisscross. Pluses and minuses by themselves don't transfer. So this would be K3P. The reason why that works is because what this is saying is I have 3 potassiums and I have 1 phosphide. So I have 3 K pluses and I have 1 P3 minus. Look, 3 pluses, a 3 minus, they're neutral. What about this? How would I crisscross this? The 2 would go here, so I have BaCl2. Again, why? This is a 2+. I have to have 2 minuses to balance that out. Next step, Al3 plus, O2 minus, Al2O3. That means I have 2 Al3 pluses. That means I have +6 over here. And look I have 3 2 minuses. That would be a -6. So they all balance. They're all neutral. So the reason why some compounds have parentheses is when you're separating a subscript from being next to another subscript, or when a compound has polyatomic ions. So all of these are polyatomic ions, but you have to signify that it acts as units. So let's think about what we would do, right? We'd crisscross this. A 2 would go here. That would look like I have MgNO3 2. It looked like I have 32 oxygens if I just put a 2 here. So to clarify, I put parentheses around it so that I know that I'm not putting a 3 and a 2 next to each other. That's to show that it's NO3 and I have 2 of them. So in reality, I have, again, 1 of these and I have 2 of those. That's what I'm trying to show. What about crisscrossing something like this? 2 would go here. And so I need to put parentheses around this because it would look like I had 42 hydrogens unless I put a parenthesis around those. And again, what does that mean? I have 2 NH4 pluses. I have 1 SO4 2 minus. What about this one? This one's a little weird. But if I put a 3 here, it would look like I have AlOH3. It looks like I only have 3 H's, but I actually have 3 OH's. So I want to signify that I have 1 of these and I have 3 of these, not just an OH3. I have 3 OH's. And then last but not least, if the charge on the cation and anion are equal, then they cancel out and you really don't need to add a subscript or anything or parentheses. So let's say you have a 2 plus and a 2 minus. That's just MgSO4. You don't have to crisscross anything because they already cancel. What about this? Plus and a minus? Just stick them together. That's ammonium chloride. What about this? Al3N3 minus, you get ALN. Just like that. So let's try this. Let's crisscross. Sodium phosphate. Sodium, Na plus, phosphate PO4 3 minus. Crisscross that. What do you get? Na3PO4. Zinc chloride. Zinc, do you remember? That's a 2 plus always. Cl minus. Crisscross, the 2 goes there. ZnCl2. Magnesium hydroxide. Magnesium hydroxide. 2 goes there. What do I get? Got to put that in parentheses. Aluminum sulfide. Aluminum's a 3 plus, sulfide's a 2 minus. Crisscross. Al2S3. Last but not least, calcium oxide. Ca2 plus, O2 minus. Calcium's a 2 plus, O minus, or O2 minus. Don't have to do anything, just stick them together. And that's it. That's how you name ionic compounds. Again, if you have any questions, let me know.